I start? Okay. Okay, so let's start our second lecture. In this lecture, we will be doing implementing on deep neural network model, and that will classify whether a sentence, given sentence, is its sentiment is sad or like happy, like that. For that, we will use a data set, and this is we are doing this as just to build our NLP concept very clear, so that when we build our project, actual project, let me show you the project which we will be like implementing at the
Let's say first this first
okay,
one, AI public well.
Okay, let me show you. You can find this video on this channel.
I don't know. Let me
see how like the same way we will build also. Same
first one is
same UI and whatever concept I have used to build this. We will be implementing this one.
Solid it is.
Okay.
I think it is.
Let's close it and let's start. It is like this project, this lecture we are going to do just for the starting, how we can start the NLP. Okay, let me put this window aside because okay, no, reset. Yeah, okay, I think it is fine. It will be enough. Okay, it is fine. And let me make it smaller, otherwise let me just keep it smaller. I think it is fine now. Okay, so let's get it started. So all of the first thing, in the previous lecture, what we have learned, we have just learned about the tokenization, how we can tokenize a sentence. Okay, there we have learned tokenization, and I think after that we have learned padding also. Okay, so both concepts we will be using in this lecture also. Okay, since we are going to do the semantic classifier, we are going to build the text of a sentence. Okay, so for that I have selected this data set. You can, I will put the link in the description. You can download this data set. How you just click here, it will be downloaded. See here, it has been downloaded, and just abstract it, whatever folder you want, just put there. Okay, see, in this data set they have given three things. First one is like test, training, and validation. For the simplicity, what we are going to do, let me close this one. Okay. For the simplicity, we will be only using this training. Okay, and for the testing, we can put our own sentence just for testing, and validation, for now we are going to skip this one because I want to make it as simple as possible. Thing is that if we know the fundamentals, then we can do anything. So my target is just to make you familiar with the fundamental, how the things is working actually. Okay, so we will be using this training only, training the data set, and this too we will we can escape for this lecture. Okay, so let me upload this one. This is our Colab, Google Colab. Okay, just come over here, click here, and wait, it is connecting now. See here, it is connecting to the server. Okay, and from here we can upload. Let me upload this one. Okay. It is uploading, and we can do what, since let it okay, now it's get uploaded. So we have to load this data set. It is a CSV file, so we are going to use pandas. So pandas is for we can use to handle files in CSV or Excel file or text file or whatever. So let me first import it. Okay, so pandas we will be using. Let me import pandas as PD. Okay, and we will be also using NumPy for to make for making converting into array. For that purpose we can use NumPy, and since we will be converting, we will be using here, you will see here, and NumPy we use actually for mathematical operations also, and pandas we can say about file handling, something like that. Not exactly, but similar to that. You can read about that on internet. Import NumPy as NP. Okay, run it. Okay, so this is our just copy the path and this PD dot, and we can check read. See, if you do this PD dot means pandas dot read CSV Excel, and you can read also JSON HTML, nearly all kind of files we can read from this pandas. So we are going to read CSV since it is a CSV file. and just paste it like this is a path. How I have done, I just copy from here. Okay, now just run it. You can see here the contents of this file. In that there are labels and text, and here like this is sequence number. Okay, serial number it is. So here text and label. Okay, so let me put in a variable. So this is like our data. Okay, so it is our data. So let me run it. Now our like all those things are now in this data. You can see like head 5 or 3 or 2. If you do this, then you will find like first three like sample. So first 2 0 1 2. Okay, so it is just how you can see the data like. Okay, now what we are going to do, we are going to do the binary classification. In that let me just introduce you with the data set first. What is inside that? See here what they have written. If you can see. Okay, okay, so here they have written that in the label, like label means this 0 1 2 and 3, they have given 4 5 levels. So first one is sadness. 0 is representing sadness. Okay, and 1 is representing joy, and 2 is representing love, and 3 is representing anger, and 4 is representing fear. So we are going to just use these two, sadness and joy. Okay, so just for simplicity we are going to do that. Okay, so we have this data. Okay, from this data, if you want like just to see what are the sentences, then you can just do this one. See here all the sentences will be appear here. Okay, and if you want like see what are the like labels, then similarly you can see it also. It is like similar to dictionary. Query is similar to dictionary. Okay, actually it is dictionary. Okay, so see here. Okay, now this thing you can do like this also, like data dot level. Still it will work. See, okay. Now so this is not much important, so let me comment that you can just run it and see. Okay, I'm not deleting it. Okay, so this is our data. Now we have to take only those text whose level is like 0 and 1. Okay, 0 or 1. Okay, so we are going to do the binary classification, and our levels will be like sadness, and what was second one? R1 it is joy. Okay, and joy. So 0 is representing sadness. Okay, and joy is represented by 1. Okay, that's fine, because they have given here you can see they have given. Okay, so here you see I didn't feel humiliated, so it is a sad sentence, I think. That's why they have given level of sad like 0. Okay, so since we want only to use level those sentences, those samples whose level is either 0 or 1. Okay, so how can we do that? You can write like this, like data dot where. Okay, if you see the where, it is like a function. It is a function. It is taking a condition and other parameters also, but you can just pass your condition and it will return the values. So what is our condition? Our condition is, okay, so what is our condition? Our condition is we have to select only those like sentence whose level is either 0 or 1. So data, and here we can say level. Okay, level equals to 0.0. We can write either 0.0 or 0. Okay, if we run it, see it has like ignored, like it has put nan at the place where there is 1 2 3 4, and wherever like level is 0, they have put in like those like sentences as it is. So how can we like remove this one? So we can do like drop, I think, yeah, drop NA. So it will like drop those NAs. Okay, still not dropped. Okay, it is a function, so we have to like call it like this, something like this. Okay, so see, so level 0 is extracted. We can do like similar for level 1 also. See, it is level 1. Okay, but I don't want to use this where. Okay, we can use some other method also. I'm going to use another method to do this. Okay, so we have this data. Okay, now okay, we have this data and we have data dot level. We can like data dot level. Okay, now is in see, it is like a function. It will return only those values. Which value will be in in this list? So we want 0 and 1. So those value will be returned from here, from this data, whose level is either 0 or 1. Okay, and we can just run it and see it whether it is running fine or not. Okay, and in between like there may be like nan like previously, so we can like use drop NA. Otherwise we can check whether there is any NA or not. Oh, sorry. Okay, let me directly put this. Like we can count this also, I think. Okay, let me just show you. Actually, this function will check whether there is any NA or not. So if there is any NA, so it will return true. Otherwise, it will return false. So if there is any NA, so I think we can use count for that. Okay, there is no such function. Count is here or not? Okay, here is count. Okay, there is no such values. Okay, it is just counting. Okay, yeah, there are like text 10,028 and labels also. So I think there is no NAs returning from this whatever we have written here. But if there is any NA, we can drop that NA. Okay, so for that I am leaving this here. For that, what can we do? We can just do drop NA. Okay, and now our data is like data with in this data what we have sad and Zoad. Okay, so let me store in this variable. Now our data is stored here. We can check it also. See here 0 1, here in this one there will be only zeros and 1, nothing more, nothing less. Understood? Okay, let me comment it out because I don't have much spaces. You can run it by your own and you can see it. Okay, now since we have to take this text and labels separately, and we can put those like in X train and in Y train, like these two are we are using as a variable to store the like X value and Y value. Y is like label and X is like our what input we are going to give. Okay, so this X train will be containing these sentences, and Y will be containing these labels, corresponding labels. Okay, so how can we get these sentences? Just take this one. Okay, take this one, and now what you have to do, and this text, since it is a dictionary. Okay, we can like run this query and it will return all these sentences. How it is returning? Let me show you. See, all the sentences is returned, but along with that they are returning serial number also. So to remove that, we can do like to numpy. We can change all this thing to numpy, and if you are like putting numpy array, then this serial number will be removed automatically. See, and what we can do, since here if you see here we were using like a list, so we can change this to list. Okay, fine. So now I think our data set is ready. So our data set is ready now. Okay, you can see the 0th one because all these things are seems to be very like everything is coming together. So we can see like a 0th, what is sentence at the 0th index. Okay, so I didn't feel humiliated, that is a sentence. Okay, now we can do the same thing with Y train. Y train, we have Y train. So for Y train we are going to use the same thing, but we don't need to convert into a list. Okay, now here we can make it 11. Okay, so it is a numpy array. When we pass to like a neural network, then actually we pass what we pass numpy array. Okay, not a list, because it will throw an error. Okay, so this is going this will we will feed directly when we will be like training our neural network. Okay, and this we are going to pre-process it. So how we are going to pre-process it? Remember the previous lecture? Okay, we are going to do the tokenization and pairing, all those things. Okay, and we can see the white train also, no problem. See, it has converted to into an array. Now now we have to do the tokenization. For tokenization we have to import the tokenizer. Understood? You can see the previous lecture, no problem. Okay, so from TensorFlow, spelling is fine or not, dot keras dot preprocessing. Okay, dot text. We do the tokenization on our text. Okay, import tokenizer. Okay, now we have imported a tokenizer. Now we can make an instant of this object, tokenizer object. Tokenizer. Okay, and we have tokenizer. Spelling is fine or not? Let me copy test. Okay, in this tokenizer, what parameter we have to pass? We have to pass the number of words. So let me make one variable. Let me give it vocab like size. It will be, let's say, 10,000. Since here like let's be in a safe zone, and let's assume that we have in our data set there are 10,000 unique words. For that we can like assign this 10,000, and this value we can put here also. What was that number of words? Okay, and we can assign this vocab size. Okay, and another thing is that here if you see OOB token none. Okay, so it is actually like if some word is, if you have written some word which is not in indexing, so like for that if some different word is coming, so for that we have to assign something. So we assume that if there is some word, let's say mango, which was not in indexing in this tokenizer, then that word will get automatically an index. Any word which will be like different, which is not inside this tokenizer, that word will be automatically assigned that a particular index, that is one. Okay, so for that we have to give like initialize it. It is OOB. I hope it is okay. I think we haven't run this one. Oh sorry. Vocab size, and from where did it has been. I think fine. It is fine now. Okay, now we have tokenizer. Okay, from this tokenizer we are going to make the tokens for all the words. So we have tokenizer dot, okay, fit on text, and our text are, what are our text? Our text are this extend. Actually it is a sentence, that sentence, remember. So this is actually our sentence. Let me put here comment. Extend is our sentences. Okay, so we are going to pass here. If you see your input parameter is text, so we are passing text. Okay, now we can run it. If you want to see the tokens, what tokens are assigned, like word index, then we can see here, no problem. Word index, just run it. See here, fully is assigned index of 944. 945 is assigned to work like this. So you can actually run this by your own. We don't have much spaces here. Okay, so our tokens are ready. Now what we have to do? We have to do the sequencing. From text we have to do the sequencing. So we have tokenizer dot text to sequences. Oh guys, text to sequences. It is not loading. Text to sequences, and in this sequence we have to pass the sentence. That sentence here, see text. In this also, that was a text. So what is that? That is extend. Just pass here. Okay. this is our sequences. Okay, it is fine. It is fine. Okay, now we have these sequences. You can see the what is inside that. You can just run it and see all these things. It is not properly visible, may not be properly visible to you, so we can see the what is sequence like for the zeroth sentence, for the first sentence. What is that sentence? Like I am talking about this one. Let me show you this one. This is a sentence. This sentence is converted to this sequence with their and replaced with their like tokens. Okay, so we have represented this sentence into a vector, integer vector. Okay, so this is now what we have to do. We have to do the padding. So for the padding, we have to first decide what should be the size of the padding. Let me first import the library for the padding. So from TensorFlow.keras dot again preprocessing dot this padding will be on sequence, so we will be using sequence and we can import pad sequence. It should recommend pad sequence. Okay, now we have imported the sequence. So from this pad sequence we can pass the parameter. What is our parameter? This sequence. See here, just hover it and you will find that sequences is a parameter for this padding sequence. Okay, so just see pad sequence, its parameter is this. So we have passed this and padded sequence. Okay, now just hover it and here we can define the max length. Max length is necessary to define because we are going to implement the deep neural network. In that we have to make sure that our input size is fixed. So max length we have to decide. So we can like put anything. Let me say just max length is max length LNTTH. Let's say max length is 100. It means the maximum length of a sentence should not exceed 100 word. Okay, let me run it. What happens? Okay, now we have max length. This max length we can use here. Max MAXLEN is to this. It is fine or not to padded sequence hasn't moved. Just run it. Is there any error? Okay, what is error? Pad sequence got an unexpected keyboard pad sequence. What is that? Oh, that is sequence. Sequences. Okay, now it is fine. Okay, so we have this padded sequence. What is inside that? We can just see. See, everything is padded now. The length of every sentence is fixed. Like every word vector is fixed now. That is 100. Like here it is 4 now. Size is 4, but here now size has been like increased to 100. And since we are doing padding, so it is a pre-padding. Padding is pre, so that's why 0 is added at the like initial. Now till here it was from the first lecture. Now onward it will be like for the deep neural network. Okay, now actually our data set is ready. This is our data set. Okay, actually it is xtrain. Okay, so we will be passing this xtrain to our neural network. Okay, we can print from here. We can see the like this one. See, it is 96 zeros and then 4, 2, 144, 3 and 450. This one we have printed this one only. Okay, now we can make our model. So deep neural network model. Okay, we are going to implement this part. Okay, since we are going to do the binary classification. Why binary? Because in Y level, if you see Y level, what was that? Y train. In Y train we have only considered 0 and 1, so it is a binary classification. So 0 we will be like 0 will be for like 0 is for sad and 1 is for joy. So it is a binary classification. So we are going to make our model in such a way that it can classify the binary. It can classify the sentence in binary. like if like it is a binary classification, so we will implement in such a way. Okay, so binary classification we are going to do, and for that we have to import the TensorFlow. Import TensorFlow. If I haven't, did I import it or anywhere? TensorFlow. Oh, I haven't imported TensorFlow as here. Now tf dot we have this model. Okay, now we can do tf dot model. Okay, that is not model, that like, or like it is sequence. We have to put the first layer, second layer, third layer, fourth layer, and at the end our at the end it will be classifier, which will say whether it is tending to 1 or tending to 0. Okay, since it is a binary classification, so we will do some kind of probability. That the probability will, if the probability will be from above the 0.5, then that will say it is like joy. Okay, and if probability is less than 0.5, then it will say it is sad sentence, like that. Okay, so we have dot keras dot sequential. In the sequential, if just hover it, okay, so it is what it has written: sequential group or linear stack of layers. So it is a stack of layer. Okay, provides training and inference feature on this model. Okay, so see how they have defined. Okay, like this. Okay, you can take reference just by hovering if you are like facing some problem. Okay, so it is a list. Let me do like this. So our first layer is going to be what? Our first layer is going to be embedding layer. That is embedding means it is like reducing the dimensionality, or you can say embedding layer is used for the feature extraction from the text. Okay, so we have keras dot layers. Okay, if you do layers, then in that layer there is one layer of embedding. We are going to use that embedding layer. Okay, in that embedding, what parameter we have to pass, we can see from here: input dimension. So what is our input dimension? Okay, so you see your we have padded the input with 100. Okay, so each sentence is like it has fixed size of 100. So here also we have to pass that since we know that our input size is 100, so input dimension will be also 100. Okay, input dimension, output dimension, and we have input length. Okay, so we have input length. So what is our input length? Here that is equals to the max length. Okay, fine. Now let's hover it. We have input dimension. So what is our input dimension? Input dimension means how many like unique word will be there. Like embedding do like it do like feature extraction. So if there are only two vector, let me show you word. MS Word is there or not? Paint. Okay, be a paint. Let me explain you what embedding actually do. Okay, no problem, we can use this. Let me use this one. Let's say it is our axis and there are only two words. One word is, let's say, sad, and another word is, let's say, that joy. So we have only two words, sad, and another word we have, let's say, joy. Okay, now if there is a sentence, that is saying I'm not happy, that means it is sad. So it should be like this, it should come like this. So embedding do like it find the similarity between the word or semantics between the words, or you can say about the sentence, how similar that is to a label. Okay, so similarity is some kind of extracting the feature from a word. Okay, and if it is like towards the joy, so it will like tend to here. So here, since we are passing the input dimension, see here they are taking input dimension here. So this input dimension actually do what? It takes the if there were like only two words, as we have shown, sad and joy in whole vocabulary, then it will be like this. Okay, and if there is, let's say, thousands of words in a vocabulary, then there will be thousands of dimensions. Understood? So for simplicity, I have just shown you how it is. But here we have to pass the size of the word, vocab size. That is vocabulary size. We have to pass here. It means there may be this much dimension. Okay, each unique word is a dimension here. Like something like that. You can read about it on the internet also, no problem. And after that we have embedding dimension. So we have embedding dimension. Embedding. Let me just have a look. Okay, output constant. Okay, so it is like output dimension. It is like initially we have thousands of dimension. Now we are going to map that thousands of dimension to let's say 16 or 20 dimension. So it is reducing thousands from thousands of dimension to 16 dimensions. So your embedding is like a reduction of the dimension. Okay, and it reduces on the basis of the similarity between the sentence or text. Okay, so our second parameter is output dimension. So let's pass the output dimension, and let's say embedding dimension will be 16 or 20 or whatever. Let me put the variable at a single place. So embedding dimension, or you can say the output dimension. Let's say it is 16. Okay, fine. Let me decrease the size. Now this was just the embedding dimension. Now we can use pooling also, since we are reducing the dimension. So we can use pooling also. This pooling is like if we have let's say we have a matrix. How I should make that? Let me use Excel. No Excel inside this. Okay, let's say we have a 1, 2, and after that let's say 4, and let's say we have a, let's say 5. Okay, so what pooling do? Since we are going to use the average pooling, so it will take the average of all these 4 and it will return a value that will be average, means it will replace all these 4 value by that average value. And so what it will do, it will just return what it will return 1 plus 2 plus 5, 1 plus 2 plus 4 plus 5, and divided by that, and it will, after that it will divide by 4. Okay, so this will replace all this, and at that place it will put only one value, replace all these 4 values, and it will put only one value, that is like average. So it is average pooling divided by 4. Okay, and in our case we are going to use the global average pooling. So in the global average pooling, it will be like it will take whole sentence, like values of the whole sentence, and here it will divide by 100. Understood? Okay, you can read about it global pooling also. Okay, layers dot global pooling. I have given just overview how it works. The overpooling pooling you can find in like CNN also. Okay, global average pooling, there are a lot of poolings, 1-dimensional, 2-dimensional, 3-dimensional poolings are there. So we are going to use 1-dimensional. Why 1-dimensional? Because our input is also 1-dimensional. Okay, when we will use 2-dimensional, like if we have a image, let's say image, grayscale image, then we can use a 2-dimensional pooling. And let's say we have a multi-dimensional image. Okay, in that case we can use a 3-dimensional pooling, like that. Okay, so we are using the average pooling, 1-dimensional average pooling. After that, here what we got till here. First we have used like embedding. Come here. Okay. Okay. So what we have done till here, embedding, what this embedding is doing, it is like we have initially like a lot of values, so it is reducing its dimension. It is reducing its dimension. Okay, it is reducing its dimension, let's say. So it is reducing its dimension to, so output dimension is what, like embedding dimension, that is here we have defined 16. So here it will be 16 such node will be here. Okay, now if we see like global average pooling, this global average pooling will do like averaging. Okay, it will replace with the average value. After that we are going to define the like dense layer. Okay, like a lot of nodes after this, nodes, and we are going to pass all this, we are going to connect all these nodes together. Okay, like this, something like this. We are going to connect all these things, and then second one also like this. So we are going to connect this. So for that we are going to use dense layer, that is here in the layers. Okay, so here we can use dense, and in that dense layer we can like assign the units, how many units we want. Let's say since from here it is coming 16, so we can assign here 16 also, no problem. After that what can we do? After that we can put here the activation function also. Okay. What is activation function? Actually it it makes the it creates the non-linearity in our system. Like if there is like x cube, you can write in form of a linear equation, like in one like if there is any sentence, like not sentence, if there is any expression 3x square plus 5x. Okay, this sentence not sentence, this expression, this equation you can write in the form of only x, not you can just use a different like you can increase the dimensionality of x. Okay, and you can replace this x square with some another, like ax plus bx plus cx, something like that. You can replace this whole thing with like this is non-linear equation. Okay, that you can put in you can convert this to in a linear equation. So here non-linearity is we use non-linearity in our function. It helps to separate, like it helps to classify the things easily. Okay, like if you didn't understood still, or if you have understood, then you can skip this part. Let me just explain what non-linearity means. Okay, let's say we have two classes, and in first class let's say we have this rate point. Let's say these are points, some points. Okay, so these are in a one class. Okay, and let's say we have some another. So these are here and these are here. So we can draw a line here. We can draw a line here to separate this. Like this yellow line is separating this red one and this blue one. Okay, but what if your red one is also here, red one is also here, some here, some here. Okay, then how you will draw a line to separate this thing? Let's say here also. So you cannot separate it by just drawing a line. Just drawing a line, you cannot separate it. So you have to draw multiple lines. Maybe still you won't be able to separate it. That's why here non-linearity comes. That's why we use a non-linear function in between our dense layer. Okay, so we do something like this. We do like something like this. Like it is not properly. Okay, I mean we draw a line something like this. Like we draw a circle. We can draw. It is very bad to use this. See, like this one is non-linear, and this circle can little bit separate this red and this blue. But just by drawing a line, you cannot separate it. That's what I'm trying to say. That's why we use activation function, and activation function helps us to create to introduce non-linear function inside our dense layer. Okay, so activation function we can use at ReLU. There are a lot of activation functions. Okay, you can read about the ReLU. You can just search here ReLU activation function. You can just see the graph. See, if any value is less than 0, like in negative, then it's when it pass through the ReLU function, then this ReLU function make it 0, and if it is a positive, then it returns y equals to x, like as it is. Okay, you can see any picture here. Less than 0 if you pass x, if it is negative, then y will be 0. If it is a positive, then it will be like same. Okay, so it is about the activation function, ReLU activation function. So in between, I'm trying to explain the mathematics also, so that's why video may be a little bit long also. Okay, now we have we can make the final layer also. At the end, let's say we have a final output layer. Let's say tens. In the output layer, there will be only one unit, and as the activation function, we can use sigmoid. Okay, you can read about the sigmoid. It gives the probability actually. Okay, you can just search it, sigmoid. Okay, see, sigmoid activation function, it is like this. So if our, like, it gives the probability, it always return the value in between 0 and 1. Okay, so our last layer is completed. Now we can run it if there is any error. Okay, let's remove this one. I think I haven't run this one. Okay, now we can run this one. Okay, no problem. Now we can like compile our model. In the compilation, we have to pass the what is the loss function we are going to use. Okay, so we are going to use the binary cross entropy. Binary cross entropy. Spelling is fine or not? Binary cross entropy. Okay, I think it is fine. Okay, after that we can use optimizer. Optimizer we use to update the values. Optimizer. And in optimizer, there are a lot of optimizer. We are going to use, there is like SGT, stochastic gradient descent, and there is ADAM also. We are going to use this ADAM. Okay, now we can use this matrix. Actually, what matrix? Okay, actually we can accuracy, RACY. This matrix will like when we will train our model, then we can see the accuracy of our model of the training. Like, what is accuracy? You can just run it. Okay, yes, compile, COMPILE. Now we have compiled our model. After that, we are ready to fit for the training. Now we can fit. In fitting, we have to pass the x and y, and the batch size epoch means how many iterations we want. Then verbose is there, and after that we have validation dataset, but right now we haven't considered that. So we will be passing here value of x and y. After that we can pass the batch size, and after that we can pass the epoch, means how many iterations it should take run. So here what can we do? We can pass x equals to, where is our data set? So this is our final x equals to x string, and what is y equals to, just take from here, where is y equals to y train. Okay, after that we can give the epoch. Let's say we want to run 30 times, so here 30, and let's ignore other thing. Let's compile it, or not compile, let's train it. So training is going on. In the first round, it is 0.5 accuracy. 0.5 means 50%. See, accuracy is very high, 99%. But be careful, if accuracy is very high or equals to 1 or 100%, it means that your model is overfitted. So it is bad thing. Overfitting is a bad thing. So see here, our model also get overfitted. So in this case, we can like overfitted means actually it connected all the points, means connected this point, this every point it actually connected, means it cannot generalize actually if we pass another new sentence. So we have to let's stop it, and in the optimizer, at the optimizer we can change the value of learning rate, optimizer. Okay, and we have keros dot optimizer, and I think there is ADAM optimizer we are using, and in that we can like pass the learning rate. By default it is 0.01, and here we can see 0.01. 0 0, let's say not 5, okay, let's say here 0.5 or 0.8, 0.0. Okay, let's see, let's save it, let's restart the session. Let's rerun all those things from the previous, and we are near to conclude the session also, because 1 hour has been passed through. But I will just let me rerun all. Okay, this is our first one, importing the libraries NumPy and pandas, and loading the dataset, and we can see the data and all these things. You can run it and see it. And after that, for the pre-processing, we are using tokenizer, and we are like doing the text to sequence. We got the sequence, and after that we are doing the padding here. We got the padded sequences. After that we have defined the neural network here. After that, okay, neural network, then optimizer we have defined, and this optimizer, it I haven't passed here. Okay, now we have passed the optimizer also. Now we are doing the fit. Okay, and let me choose any sentence for testing. Let's take any sentence from our test, because I don't know more test. I feel a little bit low. Let me copy text. It is like joy, so it should predict joy. We as expect that it should predict joy, but I don't know what it will predict. So test the data, let it be run, and in between we can. So before passing this, we have to tokenize it. Before we have to make it make it in a sequence, and we have to use the tokens actually. So we can use the tokenizer. Tokenizer dot feed on text. Then we have test data. Actually, we should do this one, text to sequence. In this sequence, we can pass the test data, and this is sequence for testing, and we have to use the padding. So let me just copy it. Where is our padding? So this is our padding. Here we can pass this the sequence test. Just pass it, and this is test sequence, and we can check test sequence. Now our input is ready, and this we can pass. Actually, this, what is this? What is this? Actually, this is this sentence. I feel a little mellow actually. This is same that sentence. Okay. Now we can, let's predict. Model dot predict. Okay. And in that predict, what we have to pass? We have to pass this x. See. Let's pass x, and anything else? Nothing else. Just run it. Okay. So it is showing 0.055. So. Okay, here accuracy we got 0.5. It means 53% we got the accuracy. So here we are getting the prediction. From the prediction we are getting the confidence of 55%. So it is saying that there is a chance of 55% that your dataset is like is a joy, and in 45% it is like sad. Understood? Okay, so that's it. So this was like very basic about the semantic classifier in natural language processing, and next onward, in next lecture we will see how we can make actually chatbot. So in next lecture we will be implementing our chatbot, actually not chatbot. In next lecture we will make one word predictor. If we write, let's say I am, then it should next word it should predict automatically that I am a good boy, like this. If we are like, it is same like in keypad of your mobile. When we type some word, then automatically it predict the next word, next possible word. Same thing we will be doing in next lecture. Okay, thank you. Thanks a lot for your patience, and I will see you in the next lecture. Okay, bye bye, take care.